Let in first case gas be compressed very fast. When gas is compressed very fast, there will be no change in heat of the system because the temperature is going to increase on account of sudden compression, right? So sudden compression is increasing the temperature, but there is no time for heat to exchange from the system and surrounding, right? So there is no change in heat. So in that case, what would I get? C, which is equal to delta Q upon m delta T. Here delta Q is equal to 0, right? But there is a change in temperature, hence specific heat capacity in this case would be 0. So this is the case when gas is allowed to compress very fast. In second case, let's say we have this container of gas, we have 1 mole of gas, 1 gram of gas, these are the gas molecules, and this time we are supplying heat from outside. This system is fitted with an movable piston. This is the piston, right? So let's say this time we allow this gas to expand slowly, like very slowly. Heat is being given to system, that means in this time C, which is equal to delta Q over m delta T, delta Q has a positive value, but when the gas is expanding, its volume is increasing, and so there will be decrease in pressure, and that will create a decrease in temperature. So on one side temperature is increasing and on another side temperature is decreasing. So that means if gas is allowed to expand slowly such that its temperature remains constant, then delta Q over m times 0. So what will I get? Specific heat capacity to be infinity, right? In third case, C is equal to delta Q over m delta T, and now in next two cases we are going to consider rate of expansion. Suppose rate of expansion is slow. When rate of expansion is low, that means that speed at which gas is expanding. Now this was a special case of these two, when we expanded the gas in such a way that temperature remained constant. That is why specific heat capacity came out to be infinity. But now what we are doing, we are just considering rate of expansion could be slow or fast. Now when rate of expansion is slow, what would happen? Change in heat is there, but definitely the change in temperature would be large, because on account of when gas is expanding, heat is being given, delta T is going to be positive, right? How can I say that delta Q is going to be positive? Because the temperature change on account of what? Expansion. Let's say, okay, if you're getting confused with this, we can change this thing by compression. Let's say we are compressing the gas at very slow pace. What will happen? While compressing, the change in heat is not that much change as compared to change in temperature, because the temperature of gas will increase because of the compressional thing. So what will happen? Delta T is going to be positive. So simple words, rate of expansion could be slow, so this C will have a positive value, and vice versa, when rate of expansion or compression is fast, this Q is going to have delta Q, this C is going to have a negative value, right?